Hello, everyone. Today we are going to talk about chemical reactions. It feels like we finally got here after everything we have learned. Every time you eat something and your body makes energy, or you bake a cake, or the leaves use photosynthesis, or you build a fire and sit and get warm. Anytime any of these things happen, you are experiencing or observing a chemical reaction. But what is a chemical reaction? Well, it's when we take chemical substances, this stuff we've been talking about, all of these different compounds, and we pull them apart and we stick them together in a different way. It's almost like Legos. We are not destroying any element. We have our base elements we've talked about, but you can take them apart, and instead of building a little rover, you can build an airplane, for example, right? So we're going to take these chemical components, we're going to figure out how you can combine them together and get something else out. And in the process, we're going to learn some extra terms about chemistry. It becomes important as we do this to use it a bit like a math equation. If you haven't learned this in physics before, nothing in our energy or matter in the universe can be created or destroyed in the course of a reaction. So you might change form from energy to matter or matter to energy if you're talking like Einstein, but in general what we do is we just conserve the same amount of it and we might change what it's doing. So we're going to say the mass in these chemical reactions we do is conserved, and therefore we can write math equations about how much of what you're going to get out of something else. So let's take a look at this. One of the most common things we talk about all the time is water, right? So water is a combination of hydrogen plus oxygen. And we're going to use in chemistry, we're going to use this arrow. It yields or becomes, and we get H2O, which is our water. So we combine hydrogen and oxygen into water. Now you might notice that hydrogen has this 2 right here and oxygen has a 2 right here. We've talked about these things before. That's to say that there are two hydrogens stuck together or two oxygens stuck together. We call these diatomic elements because they like to stick together with their bonds and are a more stable form when two of them are connected to each other. So we're going to look at these two and say, how does our conservation of mass work in this equation? Well, you can see that over here with our water, we have two hydrogens and we have one oxygen. What about on the left side of the equation? Well, we have two hydrogens, so that's pretty nice. But we also have two oxygens. So you notice there's two oxygens here and only one oxygen here. In fact, let me write this in a different way so that we can see it together. This is two oxygens. So what we really need to do is have this balanced on both sides. In order to do that, we need to make this into two oxygens. Well, to make two oxygens, I have to put a 2 in the front. Now you might notice that I'm going to write this in red because we have 2 times this entire molecule. Then there are now 2 times 2 hydrogens. So now we have 4 hydrogens. I'm just going to say, we're going to cross that out and say 4 hydrogens. We have 4 hydrogens and 2 oxygens. Well, we want to balance that out on the left. On the left, we already have 2 oxygens, so we're good. But at the top, we need 2 hydrogens. So we need to times that by 2. We need to multiply by 2. So we're going to put a 2 out in front of the hydrogen. Now what this now means is we have a balanced equation that I'm going to rewrite at the bottom as 2H2 plus O2 yields 2H2O. So what you'll notice is we write this molecule the way it forms in nature, which is 2 hydrogens stuck together. But now we have 2 of those molecules, plus 1 oxygen molecule, which is 2 oxygens stuck together, gives us 2 molecules of H2O, or water. So that is a very simple example of balancing equations. What about some of those other things we just looked at? What about rust? I didn't mention rust. Rust is one of the things that happens in nature that is a chemical reaction. And for that one, we need to take some iron and we want to react it with some oxygen. So let's take Fe, iron, and we're going to add that to some O2. And rust is the formula for rust, which in some cases, by the way, you might not know what the finished formula is. That might need to be provided to you until you've learned more. But the final formula for rust we know is Fe2O3. So we stick 2 iron molecules or 2 iron atoms together with 3 oxygen atoms to get Fe2O3. So now let's look at this. We have 2 iron, we have 3 oxygen. Over here we have 1 iron, and we have 2 oxygen. So let's look at the most complicated one, or the one that we think is most difficult. So we're going to start on the complicated side, and we're going to say, wow, we've got 3 oxygen there and 2 oxygen there. That's going to be complicated. You think about least common denominators in math or anything like that. We have to have a number that both 2 and 3 could be divided into. Or the easier way to do it is just to multiply each by each other. So we can say 2 oxygen times 3 equals 6. And this 3 oxygen times 2 equals 6, right? We could do that. So let's say if we want to get 6 on the right and 6 on the left, oh wow, sorry, I didn't mean to write 60. Oh, that was 6 oxygen. That's what that was. It looked like 60. Write the oxygen out here. So to get 6 oxygen, we're going to multiply by 2 over here and by 3 over here. Well, now we have multiplied Fe by 2, so we're going to say we now have 4 iron on the right-hand side. Well, we can make that 4 iron on the left and say 4 iron plus 3 O2 yields 2 Fe2O3, or 2 molecules of rust. So we've now written another chemical reaction. That is reacting iron with oxygen to get rust. Pretty cool. Now there's another thing you can do with chemical reactions that is kind of interesting. And that is find out if there's energy needed to make that chemical reaction happen, or perhaps energy comes out of it. So let's look at fire. When we burn something, did you realize that that's a chemical reaction? Sometimes you don't think of it that way, but you're reacting elements together to get something else. So let's do one that's kind of simple. We're going to burn propane. Propane is written as C3H8. And I'm not going to show you how to balance this equation. You're going to get more practice with this lesson. But if we add that to 5 oxygen, well, 5 diatomic molecules of oxygen, we will get, it yields 3 carbon dioxide and 4 water molecules. Don't you think that's interesting? You get carbon dioxide and water when you burn things? Sometimes we don't think about the fact that burning produces water. But what else does it produce? If you're sitting by your campfire getting your hands warm, you know that this produces heat. So we call this an exothermic reaction, meaning out and heat. So heat comes out of it. We could actually write this as plus energy on this side because the reaction produced these 2 results plus some energy. What about another common one? Photosynthesis in leaves. This one's really kind of interesting. To do that, we would say we're going to take 6 carbon dioxide. You remember that plants like carbon dioxide, right? And we're going to add that to 6 water. What does a plant need to live? Water and sunlight. So we're going to say plus some energy. And you get out of that this big molecule, which is glucose. That's a sugar, and that's what feeds the plant. Plus there's some more oxygen that comes off. So remember that plants take in carbon dioxide and give off oxygen. In the process, they use energy and they produce glucose, which is energy for the plant. So this energy that it takes in, this chemical reaction needs energy in order to happen. We call this endothermic, meaning heat or energy goes in. So we have exothermic reactions and we have endothermic reactions. And these are just a couple of the types of reactions that you're going to learn about this week, and you're going to practice writing them. You'll learn the symbols for taking this molecule and adding it to this molecule or element and getting something out. So you need to learn about the arrows and all of the different symbols that represent your chemical reactions and also how to balance them. So have a great time this week.